Today, I want to walk through a quick and very dirty example of doing some machine learning with dbt, scikit-learn, and Snowpark. So over here, I have the canonical iris dataset in Snowflake, and we're going to use dbt to create a Python model that's going to train a machine learning model. Oh my gosh, we've overloaded the term model, and execute some model training and write predictions right back to Snowflake. So we've got dbt, we have a Python model in there, and that Python model is a machine learning model. Let me show you what this looks like. And while this is running, just as a quick aside, I use this wonderful project that's not doing ML, it's actually doing something interesting, Levenstein edit distance, from Anders Swanson at dbt. So I used his template, and then I've kind of made it awful by adding in this terrible code. But thank you, Anders, for setting this up, for kind of setting the table for me. So in this case, I created a Python model. I've got my standard scikit-learn imports and pandas. I'm passing in, just borrowing from the configuration, hey, what are we going to materialize? A table. What dependencies do I need? Pandas, scikit-learn. And then I'm reading in the iris dataset from the table using dbt. So that's 2 pieces of dbt so far. The rest of this is basically just really bad scikit-learn, or an example that I copied directly from the docs with essentially no editing and no thought process around monitoring, performance, fairness, all of the stuff that actually makes machine learning interesting and difficult. I've skipped all that. So we got our X, we got our Y, train test split, standard scalar, logistic regression. We fit the entire pipeline, all 150 records, and we write out the results. And when this finishes running, as I understand, dbt is going to build this stored procedure. It's executing everything in Snowflake via Snowpark. So none of this model training, not that 150 records is a big deal, but none of this is running on my local machine. It's all running in database. And now we can check out the results here and see what we actually got as our predictions. Oh my goodness, who cares about large language models? I want to know if you can predict a flower based on width and petal length. These are the hard problems of our day.